is a medium level problem, and it states that we have been given an array in which elements are arranged in such a fashion that each element is at most k distance away from its target position. Target position is the actual position of the element in the array when the array is sorted. So we have to sort the array in the most optimal way. It is given that each element can be k distance away from it. So, uh, I will take first k plus 1 elements, put it in a priority queue in a mean heap, and the first element of the topmost element of the priority queue will itself contain the shortest of all. So, I will take I will start iterating the array from 0th to kth element, put it in a priority queue. Again, I will iterate from k plus 1 till n. Each time I will pop from the priority queue, it will give the minimum element at that index and then push the k plus 1th index from that ith index to the priority queue. This will give the optimal solution. The time complexity of the solution will be uh, okay. Let's calculate it. In to push an element in a priority queue, the time complexity is log k. To get the topmost element of the priority queue, the time complexity is log of 1. And to pop that element from the priority queue, the time complexity is log of 1. Let me check if it is log of 1 or not. Empty push pop. Okay, for pop it is log of n. Each time I am pushing an element and popping an element, the maximum size of priority queue is obviously k. So for n elements, I am pushing and popping the elements k time. The popping the elements, so the time complexity will be n log k, and since I am using a priority queue of maximum size k, so auxiliary space will be o of k. Okay, I am writing the code to make a min heap in CPP. We use a priority queue. If I declare a priority queue simply, it will be storing max heap, but we need a min heap, so I am using vector int which states the type of priority queue, and greatest int which will store the smallest element in the first. This is how it is declared. Now I am iterating the element from 0 till k and pushing the elements of the array in the priority queue. Now I am declaring this I outside of the loop so that I can access it in another loop as well. Okay, I have to add an increment here. Now iteration will go on till I is less than arr dot size, and of course an increment operator arr of I minus k. Since it is still k, I am starting from k plus 1, I is k plus 1, so arr minus k minus 1 is equal to pq dot top, pq dot pop, and pq dot push arr of I. Now pq ARR of I minus k minus 1 is equal to PQ dot pop I plus plus. Okay, there are some compilation errors. Uh, okay, I have to check how it is declared because I am doing it for the first time. Okay, these are not braces. Greatest was not declared and then greater. Okay, greater. 2, 3, 5, 6, 8, 9, 10. Before submitting, I will check for some other input as well. Yep, submitting it, copy pasting my solution to submit it from another ID, checking the comments. Okay, everyone has the same solution, but yeah, I am commenting my solution as well here for fun. Now checking editorial. Yeah, this was what I was doing it for the first time. Yeah, this is the optimal solution. Yeah, as I mentioned, nlog k, and let me check how priority queue work. Minimum heap, okay. Priority queue, how to create a main heap for the priority queue. Priority queue, okay, got it. It's just a STL. Now submitting it from my other ID. Ah, this is how the things work because I have to earn some geek bits to get some rewards, t-shirts, bags. Again doing this. Hmm. I was very consistent earlier, but then something happened and yeah, till here I was very consistent. Consistency breaked here during the interview time.